5C. Essentially, 5C and 5D come together. They've just split it up into two exercises. But the one idea is you need to understand what relations are. Now, last class, I did mention what a relation is. Does anyone remember what a relation is in a nutshell? What is a relation? It's good, we're starting somewhere. Relation, write in your own notes, it literally is just a collection of points or coordinates. So you draw an axis, you put a point, you put a point, you put a point, you put a point, label them. A collection of them or group of them is called a relation. When you sketch a graph, like a parabola, you have to understand it's not actually a solid line, it's actually made of infinitely many points. So many points that it connects to each other that it becomes a solid line. But each graph is made up of infinitely many sets of coordinates, which is why technically a quadratic is a relation, but specifically it is called a function. So today I'm going to get you to copy down as part of your notes. There are 4 types of relations that you can memorize, but I'm going to try to explain it so that you don't have to memorize it, okay? Here we go. These are your 4 types, so make sure to have it in your notes somewhere. 4 types of relations. You have what they call, and I'm going to just do it here, one-to-one relation, a many-to-one relation, and then you have a one-to-many, and then many-to-many. These are types of relations, okay? Now, what's an example of each? And I'm going to give you the idea. When you say one-to-one, what they're actually referring to, and this is why it's easy to remember and understand it, they're saying that in your collection of coordinates, it's part of a relation, that if it happens to have, for every one x coordinate, say the first one is always representing x, and the second one represents the y coordinates. In your graph, if you can say that for each point there's only one x corresponding to one y value, this is what we call a one-to-one relation. What's an example? A straight line. If I drew a straight line equation for you, every point, if you pick a point on the graph, this corresponds to one x coordinate. So you notice there's only one x, and in that part there, that one x is so annoying. This one x, I think it's my jacket. 1x corresponds to one y value. This is what we call a one-to-one type of relation. Okay, because in that coordinate there are no other points. There's only one x and there's only one y. Now, what's an example of a many-to-one? So hopefully you can start to see some of the patterns that I'm going to show you here. A parabolic shape. So an x squared graph. Listening? An x squared graph. This is an example of what we call a many-to-one. So remember, the many part refers to the x coordinate. The 1 refers to the one y value. Can you see that if I gave as an example, say 3 as my x value, the 3 can correspond to 3 squared would give you 9. So it's one y value. That's true. There's 1 3 and a 1 y value. But I can also get another 9 or another y value when I substitute -3. So -3 squared gives you the same exact value that you would if you subbed in 3. But that doesn't occur with a linear equation. Linear equation only has, if I subbed in 3, then the other one will only give me 1. There's no other way to get that one y value. So the way I like to explain it for most students to visualize, think of it as a box. Each of these boxes is a rule. So say in this example, the rule is y equals x squared. When we say 1, think of it as you chuck in a number into this machine, which is your x values. So x goes in. If it spits out one value, which is the y component, that's what this 1 represents. So when you see that 1, that's what's coming out. It's only spitting out a y value. What's the difference between a one-to-one and a many-to-one? It means that you can throw in multiple x values, hence many-to-one, many x values to get the same y value. Can you see that? So I can throw in 2 x values into this machine to get the exact same value. So I can chuck in 3. 3 squared gives you 9, or -3 into the machine still gives me 9. But in a one-to-one, there is only one x that I can throw in. So for example, y equals x plus 1. Right? If I chucked in 3, then I will get 4. There's no other way that I can get a 4 in a linear equation. This is why we call it 1x for 1y, so we call it a one-to-one type of relation. Because the coordinates that you end up when you draw the graph, every coordinate will only have one x for a unique corresponding y value. Whereas in a parabola, you can definitely see I can chuck in 4 squared gives me 16, or -4 squared also gives me 16. So it's not unique. This y value of 16 is not unique to just 4. There's also another negative version. This is what we call a many of x's values to get the one y. Okay? Here we go. I'm going to draw a line down this path here just to remind you that is actually a type of relation that we're going to be talking about. That's what 5C is about. 5D gets you to identify the 4 different types. That's it. Okay, so let's look at the other ones. So you're more familiar with one-to-one and many-to-one, which is what we call linear function, quadratic function. Okay? But in these other types, one-to-many and many-to-many, most of the time you don't normally work with this. This is why students get it confused. A one-to-many, this implies now you're going to have, for one x value, you may get many y values. What's an example of that? I'll draw a machine just so you can visualize. This is my machine. This is my rule. If I gave you y equals square root of x, you see I can throw in one x value, so say x equals 4. What's the square root of 4? 2, but y could also be -2. Remember, when you square root, there's a plus and a minus version of it. So this is an example of what we call a 1x value. When you put it into the machine, it spits out 2 y values. So this is a one-to-many. What does the graph look like? And you can start to see what I mean here. So if I draw it, this technically is what we call a square root relation. That's why when you learnt in chapter 4C, they called it a square root function. There's a key difference there. Function versus relation. If it's a relation, this is what it should look like. When you do square root of x, there should always be a plus answer and a negative answer. But why is it in 4C? You only sketch that top. And that goes back to understanding what a function is, which I'll talk about soon. But this is what we call a square root relation, not a square root function. Okay? So here, this is a square root relation because it follows the idea of one-to-many. One x value, you get 2 y values. If you want to make it a function, then you can choose the positive version of it or negative version of it. Then you either get the top or you get the bottom only. Okay? So that's a one-to-many, and then finally, you get your last one, what we call a many-to-many type. Yeah?
What's the title of that tree? Like, just above?
Oh, yeah. Relations. So many-to-many. What's an example of that? Usually you'd see it, but this year we didn't go through it, but circles is a good example of that. You see, if I draw a circle, you'll see that in a circle, you can expect that for one x value, you can get 2 different y values. See that? That corresponds to 2 different y values for the 1x. So that means when I sub in 1x, I can get 2 y values. But similarly, for that one y value, I can also get 2 different x values. So for one y, I can get 2 different x points. So that means this is a many x to a many y value. That's why we call that a many-to-many relation. Okay, so it means that you can sub in 1x and it'll spit out 2 y's, or you can put in 2 different x's to get the exact same y value. Okay, so you can have 2 x's for the 1 y or 2 y's for the 1 x. Okay, now out of these 4 types, which you need to understand them, and I hope that machine process helps you to understand. I'm going to draw the equation. This is the equation for a circle. Hopefully that diagram helps you to understand the different types, and then you remember it's always x, y, x, y, x, y. What you need to understand is what a function is. So we've been using the word function very often, but we don't know what it actually means. Here, I describe it to you, what it means, because in year 12, that's what you'll be doing. Chapter 1, Chapter 2, Chapter 3 works on you knowing what a function is. And the exams, they will ask, will you have a inverse function or will you have an inverse relation? And if you don't understand the difference between a function and a relation, then you won't be able to answer the 1 marker question easily. So in this case here, what is a function? By definition, a function literally just means, I'm just going to write underneath here to help you. Function is when you only have one y value. That's the best way to simplify it for you. So it doesn't matter, out of all the types of relations, a function is when the machine, no matter what the machine is, or the rule, or the equation that you have, it has to spit out only one y value. I can't have more than one. That's what we call a function. This is why this first two is what we call a function. See, that's why this is a quadratic function. A many-to-one is a type of function. It's a many-to-one function, which is a relation. And this is a one-to-one function, which is why we call it linear function, quadratic function. This is not a function. The reason why it's not a function is because you end up with too many y's. Okay, we have to have only one y. As soon as it says one y, that is a function.
If it's not a function, then what is a relation?
It's a relation.
Ah, right.
Yes, because all of it is a relation, but not all the relations are functions. Only 2 out of the 4 types is a function. Okay?
They're function relations.
They're just relations if they're not called a function.
Ah.
Yeah. It's like saying humans, you got that big umbrella, and then you have, let's say, the typical 2 gender categories. We've got male, female, right? If you're male, then you're male. But otherwise, you're still under the category of humans. True? So just like relations, you're either a function or you're not. And if you're not a function, then you're a relation. Okay? So, this is what you need to know. If that's a function, and I said to you before that you can have a square root function. This is why in exercise 4C, when you sketch a square root function, this is what it looks like. So why did they only allow you to draw only the top half or the bottom half singularly? They don't get you to draw both of them together. Is because for it to be a function, we said it can only have one y value. So for example, if I said x was 4, then the square root of 4 can only have one answer. You can either choose it to be root of 4 is 2. That's why this coordinate here, root of 4 is 2. That's why you only have one answer. This is why we call it a square root function. That's why you can choose it's either positive 2 or you could have the negative version, which means the answer will be 4 and negative 2. So you've learnt that to be y equals negative of root x. Okay? But that's the reason why, because you can either have the red function or you can have the green function. Together, you call it a square root relation, but not a square root function. So in year 12, that's a very typical slip that they try to slip in. They'll say sketch a square root relation, and most students are sketching that, but they're not reading it. If they're reading it carefully, it says square root relation, therefore you have to sketch both the top and the bottom component. Okay? So, this is essentially what 5C5D is. I've just given you a massive overview of what it is. Now, there are shortcuts to determine which one's a function and which one's not. I want to quickly show you right here, and you can write as part of your notes, and that will summarize 5C5D. So if you understand what I was kind of saying, you're taking your time to digest the information, that's literally the big picture of what 5C and 5D is. Here's the quick way of determining if something's a function or not. You see, the only way to get one y value, okay, one y, that means the y value here cannot have another y value down here. You see, this one has two y values. For 1x, you end up with one point here that corresponds to a y value there, but with the 1x, we can also have another y value down here. So, how they tell you is they say, do a vertical line test. A lot of kids memorize this. They go, oh yeah, VLT for vertical line test. So V vertical line test, which is written as VLT. This is, in a nutshell, it tells you or tests if function exists. Why does that work? Let's have a look. If I draw a vertical line down here, can you see it only crosses once? Because that means for each x value, there's only one y value. So that's why we call it a function, if it only crosses once. This is a function as well. If I draw a vertical line down, notice it only crosses once, which implies at this x value, there is only one y value that corresponds at that point. But in a square root relation, see a many to one, one to many, if I draw a vertical line, it doesn't fit that concept, because what this means is for one x value, you end up with two y values. So the vertical line test is just a short way to determine, are you going to have a function? That doesn't fit the definition of a function. The function says you can only have one y value, you can't have two. That's why we do a vertical line test. Because the reason why I explain this is because a lot of students mix the two. You're going to learn what we call a horizontal line test, and they will always ask me in a SAC or an exam, which one test is for the function again? That tells me you don't understand what a function is. See, if you have to ask me, is it a vertical or is it a horizontal, it means you're just memorizing things. You don't understand why we do a vertical line test. When you do a vertical line, if it crosses twice, it clearly shows you're going to get two y values. If you get two y values, that's clearly not the definition of what a function is. Function says you only have to have one y value. This can't be a function, so of course the vertical line test means you're testing if it's a function or not. Okay? So, vertical line test in a nutshell, doesn't matter which exercise you get. Let me go to 5D just to prove my point here. 5D, they just want you to check in 5D, are these functions or not? So they ask you here, which one of these are one-to-one or which one of these are functions? So is it a function? Is it a one-to-one function? So if I want to know if it's a function, draw a vertical line. Crosses once. Function. Not a function, because that ends up having two y values. Not a function there. Is this a function? Yes. Only crosses once. Means there's only one corresponding y value. Next one. Only has one corresponding y value at that point. All of these are functions except this one. That crosses twice. It implies you get two y values, and we know a function is only when you have one unique y value for every x value. Okay? So that's why this is not a function, this is not a function, this is a function, this is a function. Is h a function or not? Not a function. Because when I draw a vertical line test, you can see for one x, at that x value, I end up with two possible y values. That's not a function. So the question is, well then what's a horizontal line test do? Right? What's a horizontal line test do? Let's have a look. I'm going to go back to my notes again. A horizontal line test You can write these as part of your notes or it's in one note. HLT, this tests if you have a one-to-one. That's what it does. So if you think about the linear equation that I got just then, can you see if I did a horizontal line, this now wants to see, are you going to get multiple x values? Are you going to get multiple x values? So when I do a horizontal line, it only crosses once. That implies there's only one x value. So that tells me it's a one-to-one type function. If I do a horizontal line over here, can you see how it crosses twice? If it crosses twice, that implies you have now two x values. And if you have two x values, that implies many of these x to the one y value. Okay, so I do encourage you not to memorize these, but more to understand when you do the lines, what do they tell you? So if I go back to 5D to help you understand it, here we go. They asked, is it a one-to-one function? If I drew a horizontal line test, we can see there is an x value corresponding to one y value there, but then there's also another point over here where for the same x value, I get the same y value. This is a many to one, not a one-to-one. That's why we do a horizontal line test. Whereas if I did a horizontal line test over here, yes, that could be a one-to-one, but it's not a function, because when I do a vertical line test, not a function. That's the difference between the two. So you always do vertical line test first, then you do a horizontal line test to see if it's a one-to-one. This is going to be important when you get to 5G. 5G